Hello again, and welcome to the Rebellion broadcast system. I am your fearless leader and host, Mr. Bourgeois. We are going to introduce Chapter 10. I was thinking we would not only pace ourselves a little bit more slowly, but also coming out of Easter break, the weather's getting nice, y'all want to ease into school, and I get that. And so we're going to do that. So we're going to do the intro to the chapter, and that's all. Smoky Brokey, Roger, good to go. So if you look at page 240, and I feel like this is a really timely discussion. There's a lot of statistics popping up in the news and modeling that's happening. Probability is really the study of how likely is an event to occur. So we talk about an event, and they say, will it snow tomorrow? Well, there's a lot of modeling that goes into that. A weather forecast talks about, if you watch the weather and listen closely, especially certain meteorologists do it more often than others. They'll talk about, well, the European model says says, we'll get 1 to 3 inches of snow, but the American model says we'll get 4 to 6 inches of snow. I tend to think it'll be somewhere closer to maybe about 4. And so then, there's all this expert opinion of what are the pressure systems doing, what's hot and what's cold, and that changes the direction that the wind is blowing, and maybe snow will happen. So I used to have arguments with, not arguments, we used to have friendly debates with someone in my small group who was eventually became a PhD, a doctor in atmospheric science. And I said that the financial markets are much more difficult to predict than weather. Even though the weather people get it wrong so many times, they can usually get mostly pretty accurate. Economists in finance, it's much more difficult to predict than the weather, because the weather is based on, observable things that tend to work in a certain way, whereas the financial markets, it's so much influenced by human behavior. It's not just factors that are mostly out of our control. Almost everything in the financial markets is within the control of human beings. Anyway, probability. We're looking at an event. The event is it snows or it doesn't snow. So if the positive of it snows comes up, then what's the likelihood of that? It's usually given as it's always given as a yes or no proposition. Will it snow tomorrow? Either it will or it won't. There is no third party. There is no third or fourth event. Now you could say, how much is it going to snow tomorrow? Will we get more than 3 inches of snow? That's another event. Yes, we get more than 3 inches of snow, or no, we do not get more than 3 inches of snow. So you could also say, will we get 3 or more inches of snow? And then you'd be inclusive of exactly 3 inches. You get the idea. I really like probability for one reason, and that is gaming. As you all know, it's my passion and my business that I do. Games use dice, at least some of the best ones do. You are all familiar with the 6-sided die. It is a cube. It has 6 outcomes. You could say, okay, roll the die, and if it's an even number, then take a treasure. If it's an odd number, then a monster shows up and tries to kill you. You could design a game. That one would have 50-50 odds, even or odd. You could say, okay, you have to roll 4 or greater. That would also be 50-50 odds. You could say you have to roll 5 or better. Well, now you're looking at 1/3 odds. So the D6 is what we call it. D6 means a die with 6 sides. It's a cube. It's the most commonly used dice. But there are others. There's this thing down here, which is the D4. It is a tetrahedron, a 4-sided pyramid. It has a fair die should have an equal probability of 1, 2, 3, or 4. So 25% chance of getting any particular outcome. Over here we have the D8. D stands for die. 8 means 8 sides. It is an octahedron. It's a wonderful little doodad. There's the dodecahedron. If you read the Phantom Tollbooth, I think that's how it's spelled, dodecahedron, 12-sided die. It's got pentagons for sides. This little jobby in the middle, let's go ahead and use Galaxy Pen. This one is popular with Dungeons & Dragons, which, if your parents don't let you play it, I understand. It's got some occultish things in it. But the 20-sided die is beautiful. The D20, it's an icosahedron. What's the name of that polyhedron? These are all called polyhedral dice. Icosahedron. Yeah, you get the idea. It's hard to write with my thumb right there. The icosahedron, the reason I love it so much is because there's a 5% chance of any particular number. So if I want something to have a 20% chance of happening, I'm designing the game, I say, okay, 20% chance of happening, anything between 1 and 4, the event happens. Anything 5 or greater, the event doesn't happen. Because then I know each one is worth 5%. So I could say, hey, 1 through 10, event fails. 11 through 20, event passes. That's a 50-50 shot. But really, the best, most precise way to do it is with 2 decahedrons. Decahedrons have 10 sides. If you roll 2 of them, you see this one is a 2-digit number over here, and this one is a 1-digit number. You roll 2 decahedrons, and you can create any number between 1 and 100. So like if this one shows 70, and this one shows 6, then I rolled a 76. There's this, 76% chance of something happening. Well, then I have to roll less than a 76, or 76 or less gets me a 76% chance of that thing happening. If I roll 00, that is a 100 so 00 equals 100. That's how you use the percentile dice. So if you want your hero to have a very slim chance of hitting the giant in the forehead with a rock, say it's a very, very long odds, but it is theoretically possible, you must roll a 100, and then it happens, and it's glorious. It's the stand-up die roll, where everything hinges on one fall of the dice. It's really the glorious moment in gaming that people tell stories about after the fact. So, probabilities, oopsies. I hope my recording didn't stop. It looks like it's still going. So probabilities and controlling probabilities is a way you can control the universe in a game. Understanding probabilities using past data is a way that we can see what is the likelihood of something happening in the future. If we can extrapolate past data to make a reasonable assumption about future likelihoods, then we will do that, which is generally how things go. We have to use the past in order to help us understand and predict the future. So here we go. Part of probabilities, as you saw me doing that quick math in my head, involves fractions. And so if you look on page 241, we're gonna be bringing back over proportions, ratios, and fractions. It's kind of the meat and bones of what probability is made out of. It gets more involved than that, of course. Otherwise, we wouldn't be learning it extra. But it's really kind of the foundational work of probabilities is in understanding fractions, ratios, and proportions. So here's a quick review. Expressing a part of a, so I'm reading now, page 241. Expressing a part of a whole as a fraction and as a percent. So let's say you have 12 liters of water, 3 liters out of the 12 as a fraction and as a percent. So I have 12 liters of water. I don't know why I'm singling out 3 of those liters. Maybe because I want to make instant lemonade out of them. So if I have 3 out of 12, you see 3, it's not a pen, 3 out of my 12, my fraction is 1/4. 1 out of every 4 jugs of water, or liters of water I should say, is singled out, I guess. And then we say, what is that percent? So in order to get that percent, it says to find the percent, rewrite 1/4 as an equivalent fraction with a denominator of 100. Yeah, you can sure do that. If you want to use your calculator, you take 1 and divide it by 4, and you'll get 0.25, and you see that 0.25? Ugh, I really hate writing 5s on this thing. 0.25 is equal to 25%. So if you want to convert the denominator to a 100, that is the other way to do it. And then you don't have to use your calculator, so you can do it in your head. In your head. So in order to make 4, grow 4 into 100, we have to multiply by 25. And you just kind of have to know your math facts. And if we divide the bottom by 25, we have to also divide or multiply the top by 25. So we have 25 out of 100. And that tells us, hey, it's 25%. So the remaining, so then it says express the remaining 9 liters out of 12 as a percent. We could do this easily because we know if we have 100% makes a whole, we already accounted for 25% of it. What we're left with is 75%. So if we singled out 3/12 of our liters, we have 9/12 remaining. We could do that math over again and say, okay, 9 over 12, punch that in my calculator and see, oh, it's 0.75. 0.75 or 75%, or we can do this math right here that says, hey, I have 100 as a whole. I've already counted 25% of it. Gotcha? Gotcha. If you don't gotcha, well, pause the video and look more closely at it and phone a friend or something. Guys, let's do the quick check. Solve number 1, 2, and 3. Pause the video. Meanwhile, I'm going to, no, don't do that. Do this, haha. I forgot how to use my software in the Easter break week. All right, we're doing a quick check. I cannot see your whiteboards, so the answer to number 1 is 2/5. 2/5, express 10 ounces out of 25 as a fraction in simplest form. 10 divided by 25, we can simplify that down to 2/5. Number 2, 12 out of 40 pieces of fruit in a basket are lemons. Yum. What fraction of the pieces of the fruit are lemons? 12 out of 40. So what fraction are lemons? I know that I can divide both of these numbers by 4. If I divide 12 by 4, I get 3. If I divide 40 by 4, I get 10. That is the simplest form for number 2. Numero 2. Numero 3. If there are 36 boys in a group of 50 students, what percent of the students are goyles? Well, this one we have to do a couple of little multi-step thing. We know how many, the number of girls. If there are 50, that means there are 14 girls out of 50. 14 goyles out of 50. And we know that if the mental math, let me go through the mental math here. So the mental math, I should be able to see that if I have 50 parts, each part is worth 2%, because 50 is half of 100, right? So 14 50ths equals 28 100ths. So that's how many girls there are, because there are 36 boys, 50 total students. That means that every 50th is worth 2%. Kind of like how I know with a 20-sided die, when I'm playing a game that uses a D20, I know that every piece of that 20 is worth 5%. So if I roll an 8, I know that the odds of me rolling 8 or less are 40%. I have a 40% chance of rolling an 8 or less because I just multiply that 8 by 5. So getting good at that mental math can make you really good at doing probabilities, simple probabilities anyway. So, all right, turning the page. Zippity bippity. Once again, just a reminder, feel free to listen to me on 2 times speed so we can get through this faster. I cannot, I have to record it at regular speed. I have not yet perfected time travel. I think it will happen. I will travel back in time and let myself know if I got it to work or not. Since I haven't done that yet, it must not work. Okay, so moving on. Expressing a fraction as a percent. Express 7/9 as a percent. Round your answer to 2 decimal places. So we can multiply the fraction by 100. Write the improper fraction as a mixed number and round. That's interesting how that works. You can also try this out on your calculator. Take 7 So 7/9 as a percent, 7 divided by 9 equals 0.7 repeating, 7, 7, 7, 7, 7, 7, and at the end it says an 8. So doing it on the calculator is wonderful and cheating, but they say, hey, let's multiply the numerator by 100%, and we get 700 over 9, and then we can do that division, right? 700 divided by 9. So let's see, I know 9 would be 81, 8 would be 72. So I'm looking at 7, and I'll get 63, which leaves me with 7, and I'll get 70. And oh, look, 9 divided by 7 again, which gives me 7. And then, oh, it's going to repeat, isn't it? It's going to repeat. It's going to repeat. Let's see, 63, 7. It repeats. 7, 7, 7, 7, 7, 7, 7. That's fun. It works. Math really works. Unlike the rest of the country, but I'm just kidding. I'm working right now. All right. Quick check, you guys. 4, 5, and 6. Ready, set, go. Pause the video. Do the work. 4, 5, and 6. Write these percentages. All right. I don't know if I want to solve these. Maybe I'll do one. I'll do number 6. So here, so number 4, the answer is 62.5%. Number 5, the answer is 40%. And this one makes sense, because if a 20th is 5%, then that means a fifth is 20%. And if you have 2/5, you have 40%. Mental math. You'll start to get quick with it, I hope. So number 6, 24/9. This one is tricky. I'm going to do number 6 out. So number 6, 24/9. So remember the method. Multiply the numerator by 100. So 240 divided by 9. And remember, our fraction is going to be, what am I saying? Our answer, so when you see an answer in a decimal form, like 0.75, we know that means 75%. However, we already multiplied this by 100, so it's not going to come out 0.75, it's going to come out 75. Well, it's not going to come out 75, it's going to come out, the mystery answer that it's going to come out. So 9 goes into 24 twice and gives us 18. It's 6. We bring down the 0. And then 9 goes into 66 times, right? And that gives us 54. And then we have a 6 here, and uh-oh. Spaghettios, did I mess up? I might have messed up. Oh, I didn't multiply by 100. I multiplied by 10. I was like, this isn't wrong. All right. But guys, we already divided 9 into 60. We get 6. And so we know that this 6 is going to repeat because it's going to keep doing that. It's going to be a 54. And then we're going to have to put a decimal point there, bring down a 0. And we're going to keep getting 6s. So 266%, round to the nearest hundredth. We have 266. Final answer, 266 and 67 hundredths percent. It's the final answer. That is the correct and truest and bestest answer. Moving on, by the way, we're on page 242. I already did do that. Okay. So now let's see if we can express a percent as a fraction or a decimal. Try not to have too much fun, you guys. I know some of you definitely are having too much fun. Social distancing. What are the odds that I roll down my window at the drive-in church tomorrow? Oh, today is Saturday when I'm making this recording. What are the odds that I defied the government decree that says you have to have your windows up when in a drive-in church? I'm not really a rules person, so the odds are very high that I defied that silly little rule. Not trying to give anybody coronavirus, but my car's already 6 feet away from everybody else's car, and no one's sneezing at each other, so I think it'll be just fine. But Express a percent as a fraction or a decimal. Let's express 55% as a fraction in simplest form. You guys remember how to do this? So 55% is the same as 55 out of 100. So 55 out of 100, if we simplify this, well, it could easily divide by 5, and then we have 11/20ths, right? That's easy to see. 55 divides by 5, and we know 100 divides by 5. I love this. I love that 100 is evenly divisible by 25 and also 20. It just makes math easy when it comes to percentages. Easier, I guess not easy, but easier. So if we did 126% as a decimal is easy. If you have 126%, you just move the decimal point 2 places. That's how that works. So 126% is the same as one whole. Remember, 100 is a whole. 100% is all of something. 100% of an orange is the whole orange. 100% of a watermelon is the whole watermelon. You get the idea. Or do you? Do you need one more example? 100% of the pizza is all of the pizza. No more, no less. So 126% of something is one whole. That's one whole right here. One whole. And also 26 hundredths of a whole. So if I say I have 126% of a pizza, I have the whole pizza right here. I also have another 26 hundredths of it. I don't know how I did that. It's 26 hundredths of another pizza, I guess. I took someone else's pizza. About a fourth, give or take. Mostly take. I took someone's pizza. So, quick check, y'all. Let's do them. Let's do all of them. Do all the quick check problems. Pause the video, do them. Then unpause when you're done. Okay, you're done. Good job. So number 7, 54%. Write that as a fraction. How many of these do I want to solve? I mean, I am having a lot of fun. 54% is 54 hundredths. We can simplify this by dividing by 2, and then we'll get 27 over 50, which is the simplest answer as it turns out. So number 1, 27 50ths. Or number 7. Number 7 is 27 50ths. Number 8, they say to write it as a fraction or a mixed number in simplest form. Number 8, the answer is 39 over 200. That is the simplest form. If you don't see it, try working it out again. Because 19.5% is 19.5 over 100. You can't have a decimal in a fraction. It's like a big no-no. So we have to multiply by 10. So we're going to get 195 over 1,000. And then you'll see that it simplifies down to 39 over 200. 39 200ths. Which is just messy math. Try dividing a pizza into 200 equal pieces. Number 9, 1.4% is the same as 7 over 500. These are really hard, you guys. These are really fun. Good job. I'm going to do this one too. So 1.4 over 100. We can't have a decimal there, so we're going to make it 14 over 1,000. And we see that these both divide by 2. And so then dividing by 2 gets us down to 7 over 500. 7 is a prime number. Galaxy pen for prime numbers. 7 is a prime number. Ow. And so that means we're not going to be able to simplify that anymore. So 7 over 500 is what we got. Number 10. The answer is 1. So mixed number would be 1 and 3/20ths. And you should know, because 115% is bigger than 100, you should know you're going to get something bigger than one whole. We have one whole plus 15%. And remember, every 5% is a 20th. So we have the one whole, and Then we have this extra 15 hundredths. And like I just said, 5% is a 20th. That's the fast mental math of it. If you want to work it out longhand, be my guest. All right, now let's do 11, 12, 13, and 14. You want me to give you the fast answers? And then I'll let you skip. So 28% is the same as 0.28. 9% is the same as 0.09er. 34.5% is the same as 0.345. And 256% is 2.56. Let me write these out. You may skip ahead the video to the point where I stop writing them out. 0.28, number 12. Actually, I'll tell you what, I'll write it the same way it's in the book. Number 12, 0.09er, number 13, 34.5. If you are still watching me do this, you are still watching me do this, you're probably the type of person who stays until the end of the movie to watch the credits. To see if anything fun is going to happen at the end of the credits. And then you're always upset when nothing does. I am that guy. I'm like, nah, I paid good money to see this. I'm watching every single name slide up that screen. 2.56. There it is, you guys. You did it. You did it. This is what your answer should look like. If they don't look like that, you can send me a message and be like, hey, Mr. Bourgeois, why don't my answers look like that? What am I doing wrong? And I can work more closely with you. I'm glad to do it. Always, always, always. It is never a tedious or onerous task for me to come alongside you one-on-one and figure out a thing. I love it. Sometimes I'm not quick with responses. That doesn't mean I don't love it. It just means that, you know, yeah. This is the play button. Boop. All right, guys and gals, guys and dolls, we're on page 243. There's end at the light of the tunnel, or something like that. Expressing a ratio as a fraction or percent. A ratio that compares a part to a whole can also be expressed as a fraction and as a percent. I think we already knew this, but like I said, this should be review. But when we say the ratio is, yeah, let's just read. The trees in an orchard are pear trees and apple trees. The ratio of pear trees to apple trees is 7 to 13. So pears to apples. I really, like I said, I've always kind of had a hard time with ratios. Mind your P's and your A's. Pears and apples. What? Actually, the old saying goes, mind your P's and Q's, because sometimes people would write their P's backwards and they would look like Q's. Fun story. All right, what fraction of the trees are pears and what percent of the trees are pear trees? So if the pears to apples is 7 to 13, in order, remember, so this is, I know this tripped up some of you, many of you actually. How do we convert this to a fraction? Because remember I said a ratio is part to part sometimes, or kinda, sorta. I'm kind of shrugging and making hand gestures that you can't see. So here, kinda, sorta, there. Those are my mouse gestures. So like part to part. The fraction is always part to whole. So if we have pear trees and apple trees and no other kind of trees in this orchard, then we know that the total number of trees is 20. There are 20 total trees. Which means, what fraction of the trees are pear trees? The fraction is 7 over 20. That's the fraction. What's the percent? Well, we have to do some math to figure out the percent. Converting things into a percentage is wonderful. Here's why. Because a percentage makes it all a common language. Even though percent is more work, when we talk in percentages, we can all be speaking this. We can compare apples to apples. No pun intended. We can compare things using the same language. It's like if I'm talking about how many Saudi riyals something costs, and you're like, what? Or if I say, yeah, that book costs 7 million Japanese yen, and you're like, that means nothing to me. What? That sounds expensive. What is that in dollars? And then I have to convert it to dollars so that you understand it. When we use percentages, it's easy to compare multiple different kinds of ratios all together. I can see exactly how much bigger something is than another ratio when I convert it to a percentage. So let's do that. So 7 over 20, convert that to a percentage. And they say, yeah, let's do that. So they do it the fun way of multiplying by 100 and then doing that. I'm going to do it my mental math way. So follow along in the book, see how they do it. They multiply it by 100 and then divide that out using division. That will work for any fraction. But when I see 20th, my brain says, aha, I know every 20th is 5%, and so I take 5 times 7 and I get 35%. I use mental math whenever I can because it makes me look smart in groups. And I'm extremely vain like that. Not really. I like mental math because I feel like it makes me keeps my mind sharp. And I probably wouldn't be doing mental math quite so much, except that I play games and also I'm a math teacher. So I'm trying to get good at that. I'm trying to stay sharp with that, even though I'm crazy, crazy old. So old. So guys, quick check. We're doing 15 and the 16. It's going to be a good time. All right, a flower bed contains marigolds and zinnias. The ratio of marigolds to zinnias is 7 to 11. What fraction of the flowers in the gardens are marigolds? Write your answer as a fraction in the simplest form. 7/8. 15. Number A. 7. Sorry, I said 7/8. 7/18 is the actual answer. 7 out of 18. And what's that percent? Number B. The percent. Honestly, I don't have the mental math for 18ths. I have it for 20ths, but not 18ths. So we're going to take 700 and we're going to divide it by. Wait, how do we do this? Yeah, divided by 18. That's right. Along the division. Okie dokes, you guys. Let's see. 3. Because if I had 20, that would be 60, but I have 6 less than that, so that would be. What did I say? 6 less than that, so it would be 54. Yes, pretty sure. 70 minus 54. Let's see, 16. It is late at night when I'm doing this video, so I'm maybe not be as sharp. And just kind of eyeballing this right here. 18 probably goes into 160 9 times. Also, I'm cheating because I see the answer is 39%. And it works. 39% is the answer. Woo! If you guys had your calculators at this point, I would not fault you for doing calculators, but I think I will allow calculators in the checkpoint. I have not officially decided that. That's like a rumor that just sprung up out of my own mouth, which is weird, spreading rumors about yourself, but I think we will have calculators. I think. I'm leaning towards having calculators on the checkpoint. Number 16, a bookcase holds 20 history books, 23 sci-fi books, and 49 mystery books. Murder Most Foul. 16A. What fraction of the books are science fiction books? So the total number of books, we have to add those up. Let's see, 49, 69 plus 23 is Is it 92? Mental math. It is 92. Okay, I used my calculator. I cheated-ish. So 23 over 92. Oh golly, what do we got here? I don't know. It simplifies down to 1/4 because I'm using the answer key. That's the answer, you guys. What do they divide by? Can you straight up divide? It does. Oh my gosh. Okay, so 92 is evenly divisible by 23. I mean, it has to be. Otherwise, how else would you get 1/4? All right, number B. If you keep telling me that B cannot be a number, I have some serious issue with you and your attitude. So what percentage of the books are science fiction books? Okay, 1/4 is equal to 25%. At this point, you ought to know that. Put that calculator away. That's right, I'm talking to you, Sadie, Johan. I already picked on Sadie. Who else can I pick on? Sophie, put the calculator away. You know that 1/4 is 25%. There you go. I have to visualize the room to pick on somebody. All right, turning the page, y'all. Wiki, wiki. So I just want to say, for all of you who were having Easter break and you were like, man, all I really want to do is watch a math video by Mr. Bourgeois. I'm sorry, but now, hopefully, all your dreams have come true. And here we are. Page 244, solving a histogram problem. The table shows the heights of 78 trees in a park rounded to the nearest foot. The height is given in the column on the left. I'm not going to try to recreate it. You can look at your book. Look at your book. I command you. And then the column on the right is the number of trees that have that height. That's how a histogram works. So you go out with your yardstick or whatever you're using to measure your thingamajiggers, your trees, and you say, aha, how many trees are between 60 and 69 feet? You count 11. You plot them on the little chart, the little histogram chart. Actually, you plot them in the table, and then you chart them, graph them. Potato, tomato. Table, and then a graph. And then it visually displays that information. So, the heights of the trees are 25, wait and see. Heights of 25 trees are at least 90 feet. 42 out of 78 trees have heights between 70 and 89 feet. And 54% of the trees are from 70 to 89 feet tall. Yes, they give it to you as a percentage, and first they count, and then they give it to you as a percentage. So, you have graph paper in your notebooks. I know you do. I gave them to you. So, we're going to pause the video, do quick check number 17, and then we'll call it a day. Boom shakalaka. Okay. So number A says draw a histogram. There are 15 that are from 10 to 19. I'm gonna have to draw really small. And then the next little plot thingy goes up here. We're at, this should be like 33, right? So what you can do, marking 33 is weird. So if you're like me, you might do that. You might have a 35 up here. And then over here you might have a 30. And so then your chart would hit right in betwixt those two. And then this is tiny writing, between 20 and 29, 20 to 29. And then we'll have, let's see, 18. I should color code these, right? Look up. So that's the a 30 to 39. You get the idea. And then there's the 24s, which would be like, I don't know, this is not very good drawing to scale, because look at this. 0 to 15 is this much, and then 15 to 30 is that much. Yeah, I didn't scale this very well, did I? That's okay. That's why it looks wonky and distorted. So hopefully your little histogram can look like that. And then if you drew your little histograms like kind of skinny and apart, that's fine too. They don't have to be necessarily snugged up next to each other. You can social distance your plots 6 feet apart. 6 feet, please. Cover your mouth. All right, so hopefully you have a wonderful histogram that is more beautiful than mine. And question number B. How many steel bars have a mass between 10 and 39 grams? So 10 and 39 is going to look at the top 3 rows. So we have 15 plus 33 plus 18. We're going to add those together, and we're going to get 66. That's the answer to number B. And then number C. Let's just slide the board down. I'm tired of erasing. Number C. Here. What percent of the steel bars have a mass of at least 20 but less than 50 grams? So between 20 and 50, we're looking at 33 plus 18 plus 24 divided by the total number, which is, oh, I didn't actually calculate this. Let's see. Oh, there's 100 steel bars. Oh, and it's also given. They tell you 100 steel bars. Divided by 100. Well, that's easy math. So 33 plus 18 plus 24. I could do that in my head, but like I said, it's late at night and I'm tired. Oops. Come on, calculator, clear out. 18 plus 24 plus 33. Order of operations, it's 75. 75 over 100, which equals 75%. Guys, we are done. I hope you have the good ones, and I will talk to you later.